Partial fraction decomposition. Write the following fractions. So we got 3 here as a sum of simpler fractions. So the variable could be x or y, or in this case s. So this is a complex fraction. So if you want to integrate, it's not possible. Or in differential equations, if you want to find inverse Laplace transform, it's not possible. So we can write this as a sum of simpler fraction. So all we have to do is the bottom, because the bottom factors, so it's possible to write as a sum of simpler fractions, okay? So let's factor the bottom, okay? We know that s is squared minus 5s plus 4. So square means we'll have 2 binomials. 4 means 4 times 1, 4. 4 and 5 make 4 and 1 make 5, so minus minus. So what we're going to do is we let this fraction be 1 over s squared minus 5s plus 4 because we got 2 fractions, right? So it doesn't matter which one you write first. So let me write s minus 1, s minus 4. This is degree 1, so we want to write just a constant, which is degree 0, b. So this is what we want. Now we need to determine the values of a and b. So when we say this equals, that means if I multiply through by this product, you don't have to show, but I'm showing for the first time. If we multiply by this product, s minus 1, s minus 4, I mean this one is essentially s minus 1, s minus 4, so this one and this one cancel, so 1 equals, when we multiply here, s minus 1 cancel, a, s minus 4, plus b, s minus 1. So this is essentially the top 1 equals a times s minus 4 plus b times s minus 1. So this works when we have distinct factors on the bottom. So this is true for all s. Now we want to choose values of s so that we can isolate a and b. If we take s equals 1, then what happens? This is 1 equals 1 minus 4, negative 3a plus 1 minus 1, 0. So the whole thing is 0. So this one, or what is a then? This is negative 3 times a, 1 over negative 3. So a is negative 1/3. Okay. In the same way, let's take s equals 4 to make this 0. Okay. So 1 in the left hand side equals, this is now 0 plus 4 minus 1, 3b. That means 1 equals 3b, so b equals 1/3. So thus, let's go back here. So this fraction, whatever that fraction is same as a over this, and a is negative 1/3 over that plus b is 1/3. Okay. Now we can integrate or find inverse Laplace transform. But here we are just writing this complex fraction as a sum of 2 simpler fractions. Same thing for the second question. And now let me just write, let this equals, so the bottom factors again, otherwise we cannot do this. So s is squared minus so 5 times 3, 15. To get negative here, positive there. Okay. Double check this one. So this one is s minus 5. It's 3. Okay. This is degree 1. So we just write constant. Constant. Okay. This is our assumption. Again, we need to determine the values of a and b. If we go through what we did in the previous, we can multiply through by the product, s minus 5, s minus 3, then the bottom cancels anyway. So this implies the top equals, okay, a times this one, b times s minus 5, okay. So here we have 1 on the top, but we have some function on the top here, and this is true for any value of s. Now we take s equals, let's say, try to make this 0, so take -3, and -3 minus 2 is -5 in the left, so -3 plus 3, this part is 0, -3 minus 5, -8b. That means b equals -5 divided by -8, which is simply 5/8. Okay, that's the b value. Now we take s equals 5, 5 minus 5, 0. Then 5 minus 2 in the left side, 5 minus 2 is 3. 5 plus 3, 8a, plus 5 minus 5, 0. So, or from here, a equals 3/8. Okay, thus this fraction s minus 2 over s squared minus 2s minus 15 is a over s minus 5, so 3/8 over s minus 5 plus b over, b is 5/8 over s plus 3. Okay, now the third one is slightly different. The bottom, let's factor the bottom. We got s cubed minus 9s, so we can factor s out, and we have this. Now this is difference of two squares. 9 is 3 squared, so this is s plus 3, s minus 3. So this is a cubic polynomial on the bottom, so we are getting 3 factors, 3 distinct factors. Okay, so it works in the same way. So let this be. Now we got 3, so let's write anything, doesn't matter which one you write first. Okay, this is degree 1. I mean, there's a power 1, which we don't write. So this is degree 0, just the constant on the top. A, B, C. So we assume this. Then this implies, like last time, 1 equals, so these are distinct, so A times the other two. Plus B times other two factors, B times C times. Okay, now we're going to take nice s values so that we can isolate A, B, and C. S minus 3, so let's take 3. If we take 3, so in the left side, 1 equals, now 3 minus 3 is 0, so this factor is 0, means whole thing is 0. This is also 0, 3 minus 3 is 0. So this is C times, this is 3. 3 plus 3, 6. 6 times 3, 18. C times 18. That means C equals what? 1/18. Okay, let's take S equals -3. So -3 plus 3, 0. So this factor 0 means whole thing 0. So negative, here -3 plus 3, 0 means the third part is also, third term is also 0 here. So this will be 1 in the left side, and this is the 1, equals B times -3 times -3 minus 3, -6. -6 times -3. That's the positive 18 again. So that means B equals 1 over 18. Now let's take s equals, pretty much we are taking the zeros of each factor. So s equals 0. I mean, we should have taken this. Okay, easiest one. Then 1 equals, so look at it, 0, which is a factor. So this is 0, this is 0. So a times 0 plus 3 is 3, times 0 minus 3 is negative 3. 3 times negative 3, negative 9. So a times negative 9, so a equals 1 over negative 9, which is same as negative in the front, 1 over 9. Okay, so thus this complex fraction is a over s, so negative 1 over 9 s plus b over c over okay, that's final. And we can take, if we had x, then we can integrate easily, or we can find inverse Laplace transform in differential equations. So depending on your class, this is what you need to do.